So, in the last video, we have created the Hello World application. This time, we will learn about the data types in C. So for that, I'll create a new script. I'll call this datatypes.c. So like the Hello World, we can also have a main function inside it. So I'll just copy this part because I'll also need the stdio.h to print stuff on the console. Now I'll just remove this print statement. Okay, so the first data type that we'll learn is char. So char. This stands for character. So let's create a char. So to create any variable in C, you have to specify the variable type first. So over here it is a char type. Now we have to give a name. So for name I can give it my char. Okay, so this is how I have created a variable called my char, which is the data type of char or character. See over here that I cannot start a variable name with numbers. Okay, so like I can start with underscore, but numbers are strictly not allowed. Also, I cannot have any space inside my variable name. So whatever space you want to do, either you can follow this snake case, or you can type like this my char instead of space. The next word can start with capital letter. So this is called camel case. I prefer this underscore. So let's assign a value to this. I'll assign a single character A. Now we have created a character and initialized this data with the value of A. So value of A, if I hover over it, this is actually 65. So whenever we print this, so I'll do printf, and then to take in a character kind of variable inside a string. So printf expects a character array basically, which we can call string. So for string formatting we can do %c, c for char, and then we'll put a comma and pass in our variable, so my char. So see the syntax over here. We have created a character array and specified a %c. This is a placeholder where the value of this variable will go into. So I can write before or after this like my char is colon, and that's it. So like this is how we are specifying the template of the string, and this placeholder will be replaced by the variable that we have passed in. So if I want to compile this, so gcc, I'll call this file itself, so datatypes.c. So this will actually override the contents of a.out because after this I have not specified any output file. So by default it will take a.out or a.exe. So let's run this. You can see that my char is A. So it has printed successfully, and we can pass the character data in the formatted string. So this is how we have created a character. Now what this char is actually, this is 8 bits. So size of this, if we want to print, so printf size of char is, I'll do %i, I stands for integer, because when we want to check the size will be an integer. So a very convenient function in C, that is a built-in function, is size of. After that we can pass in my char, okay, or we can actually pass in the data type itself. So okay, this is actually returning unsigned long, so it's fine, we'll not have as much issue. So I'll just typecast it to integer. Typecasting we'll learn properly later. For now just we want to check the size of char. So for that I have done this. Now if I build this in the terminal, So the build is done. Now we can call a dot out, and you can see that size of char is 1. So size of char, this will return 1. This, the unit of this is byte. So actually this means this is 8 bits. What is 8 bits? 8 bits can be thought of like this, that you have a list of zeros and ones. So like 001, so 001100, like this. Okay, 1 2 3 4 5 6 7 8. Okay, so you can think it like this, a list of only 1 bit datas. So this becomes 8 bit. So this is essentially 8 bits, which is also called 1 byte. So whenever we create a variable char like this, we have specified over here, this kind of 8-bit data will be reserved from the system RAM. So this will be reserved from the system RAM. So RAM stands for random access memory, and this is the primary memory that the CPU directly talks to. So RAM also have two parts. So the first part is called stack and another one is called heap. So these are two parts of RAM. Actually, stack and heap are not physical partitions inside the RAM. Instead, you can think of them like stack is pre-allocated memory while heap can be allocated during the runtime. So pre-allocated and during the runtime, this kind of words we'll learn when we work with memory. So things like malloc and all, which will come in next 3 or 4 videos. So let's reserve those topics for that time. And so basically we have created this 8-bit data for to store this char. Now this char data type is 1 byte. Let's go to the next data type, which is int. So similar to this, how we can create a char variable, we can also create a int variable. So for that I have to mention the type first, and I'll call this my int. Okay, so after that I can initialize a value, let's say 10. Now I can similarly printf my int is. Over here I'll do %i, which we have actually used before also. %i stands for a placeholder for an integer type. So after that I need to pass in my integer. So just like this. Okay, so I'll actually build and run at this point. And if I run this, we can see that my int is 10. Actually, these are all coming in one line. So let me put an escape character. So I can write /n after each line. This will essentially print a enter. Basically /n is an escape character. So over here in the comment I will type it. So this /n is a character. Okay, this is new line character. Okay, this stands for whenever this is encountered while printing or while doing file operation, any kind of string related operation, this will be treated as you have entered, like you have pressed the enter button. So if we build and run this again, so I'll do this. See, everything is on its own line. So my int is 10. Now let's see the size of int. So printf size of int is so I'll do the same syntax /i for integer, and I'll just put a new line character also, and I'll typecast this size of int. So let's see what is the size of int. Now let's build this and run. See, size of int is 4. So this means this is 4 byte, which is 32 bits. 32 bits means this kind of array, okay, but 32 such zeros and ones combination. So like you can already see that like if there are only limited number of bits in an integer, so there will be upper and lower limits of integer also, right? So how integer is structured is like this. So you have first a sign bit, okay, so this list we are looking into. So you have first a sign bit, so this sign bit is first. If this is 0, so if sign bit sign bit is 0, then it will be this actually depends on the implementation. So we can think it for 0 it is positive, for 1 it is negative integer, okay. So after the sign bit you have how many more spaces? So there are 31 more spaces left, so 31 zeros and ones. So you can see that sign bit can already differentiate between the positive and negative. So the maximum value of the rest of the data can be, so max of int can be 2 to the power 31, right? This is positive, and minimum can be 2 to the power 31 but with a negative sign. So this is how the maximum and minimum of integer can be calculated inside the C programming language. This is because how the integer data type is predefined inside the language. So this is actually quite enough margin, and if you are required for even larger numbers, then you have to allocate your custom memory and implement your own version of larger integer. So this integer data type, okay, so my int, I can do all the usual operations, like I can do integer equals to integer plus 1 or plus anything, plus 5 let's say. Then I can do this print statement, so like my integer will be updated with the new value. So if I build and run this, you can see that my integer has been updated to 15 because 10 plus 5 will be 15. So like I can put some other values also, okay. So with integers I can also do multiplication, division, and all the mathematical operations, modulus. So I can take a modulus of this whole thing, so let's say modulus 9. This will give me an integer in fact. So if I build and run this, see, so this is our answer. So like this integer can be used for arithmetic operations and all. So next we have float. Float is floating point numbers. Integer was covering the whole numbers as well as the negative counterparts of the whole numbers. Now we have decimals and all, those will be handled by the float. So let's create a float. I'll call this my float, and I can assign it any value, so any random value. Actually I am assigning it, but it is not mandatory to assign while creating the variable, so you can assign it later also. So we'll do printf my float is, and then for float we have to do %d. D stands for digit, so %d, after that I'll pass in my float. Let's see the value of the float. So in the console, I'll first build this. Actually, it is okay. We have to pass in %f. So this compiler actually is helping me out, like what I have to put over here. So I'll build this again. And if I run this, you can see that 2.67, and then it has appended some more zeros, because whenever we are creating a float, we're like reserving a particular size of memory. Even if we are not using the whole memory, the memory is reserved. So let's see how much memory the float is taking. So printf size of float is percent I will do similar to last one, and then I'll do int, like typecast int size of int, sorry, size of float over here. We want to see what is the size of float. So if I like build and run this, so size of float is 4. So once again, you can see that size of 4 is 4 bytes, which means 32 bits. So this is also 4 bytes equals to 32 bits. So like integers, let me just put this line ending over here first. So like integers, float also has positive and negative counterparts. So the data that will be in the memory for creating a float variable will look something like this: sign bit. After that, depending on what is the like specification in the system, there will be the integer part of the float. So some zeros and ones will be integer part of the float. After that, there will be the decimal bit. Let's say decimal bit, okay. And after that, the floating point data basically. So this kind of structure can be found inside the RAM. So this will interpret the floating point number, or the float number variable in the C language. So we can actually do mathematical operations on float also. So like my float equals to my float into, let's say, 2.9 f. So whenever we are assigning a float, we mention f after it to specify that this is a floating point number. And now I'll just print the updated float. So like this, can build and run this. So my float is 7.743001. Like I think this one came because of like rounding error, but this kind of floating point operations can be done in the C language. So we have covered the basic 3 data types. So there are unsigned version of these also. So like I said that for integer float, for the first bit will be occupied by the sign bit, so positive and negative. So and keyword unsigned can be used while declaring the variable. So if you do unsigned int, and let's say you create a my new int, and I'll assign 10 to it, let's say 20, okay. Okay, so we'll printf this also. And over here %u for this unsigned int. So we have passed in our variable in the formatted string. So let's build and run this. As you can see, the new int is 20. Now if we pass a negative 20 over here, let's see what happens. See, this is a basically garbage value, because the alignment is not correct, as this is not expecting the like before, this data is not expecting this sign bit in the beginning. So this sign bit is not expected, but anyways we're trying to put a value over here. So when we're reinterpreting this inside this print statement, we are not actually seeing the data properly. So assigned data is assigned to an unsigned int, which is wrong. So over here we don't have any sign bit. So this can be any kind of data. So one thing immediately you can notice that if the sign bit is gone, so previously our range was max was 2 to the power 31, minimum was minus 2 to the power 31. So now our range can be max will be 2 to the power 32. Okay. And similarly, minimum can be 0. Why 0? Because you don't have a sign bit. So the lowest that it can go is all zeros in the 32 bits. So something like this, like all zeros up to 32. So since this 0 does not represent a positive or negative, so the least it can go is up to 0. And for all and to reach the maximum value, it will have to be all ones like this. So like this format. So when they are all 1, then the value will be 2 to the power 32. So unsigned version can be used to increase the range by like 2 times of int, but also while sacrificing the negative part of the int. So this is actually the whole number basically including 0. Now a boolean data type is there also, but that is not like by default added, but that is in the standard library only. So std bool, like this is actually very stupid to use, because if we go to the std bool header file itself, we can see that true has been assigned to 1, false has been assigned to 0. So these are nothing but integers. So the data type bool is basically integers. So let's do it anyways. Bool, not boot, bool. Okay, so bool stands for boolean, 0 or 1. Now like before, let's create a bool data type. So bool, my bool will be, let's say, true. So we can print this also, printf my bool is. So I can actually pass this %i, let's see, and then my bool. Now let's try to build it. So my bool is 1. I forgot a line ending somewhere over here. There we go. So the value of my bool is 1. 1 stands for true and 0 stands for false. So true is 1 and false is 0. So actually the bool data type is a like huge waste of memory, because printf, let's do the size of bool is, so %i I'll do for integer, then I'll int typecast the size of bool. So let's see over here, the size of bool is 1, which once again this is 1 byte equals to 8 bits. So true or false can be represented with only 1 bit, but we are anyway reserving 8 bits just to represent that. So like this is kind of a limitation of the C language itself, because it is like aligned with 8 bits. So we cannot go below 8 bits. So with bool we can actually like do if else etc conditions. So those conditions we'll learn in the future videos. So this actually concludes the data type NC. Thank you. Thank you for watching this video. Thumbs if you liked it. Do share it with your friends and family, and make sure to subscribe for more content and let me know in the comment section below.